Hello, and welcome to this International Society of Automation webinar. My name is Matthew, and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenter. With us today, we have Jim Gilson, technical leader coming to us from Dragos Incorporated. To read more about Jim, please look at the Speaker Bio window right next to the main presentation window. And Jim, welcome to today's event. And with that, I will pass things along to you to get started.
Thanks, Matthew. So today, I wanted to talk to you about an effort that the ISA 99 committee took on with the Industry IoT Consortium. This effort was to basically help them map what they call their security maturity model to the ISA IEC 62443 series. So we'll start out today just talking a little bit about the history and purpose of what the document, what the whole process was all about. We'll go into a little bit more about their IoT security maturity model itself. And then I'll talk to you a little bit about the work process that we actually used to develop this mapping. And then I'll actually go through sort of the results of what we came up with and work through an example for one of the sections that they have in their model. So what happened was that in 2020, the IIC published their IoT security maturity model. And this was basically requirements for IoT product suppliers. They were developing this idea of a security maturity model which would allow organizations, product suppliers, to develop different levels of products and sort of design them to work within different areas. And we'll talk a little bit more about the levels here in a few minutes. In January of 2021, the IIC approached ISA 99 basically after they had started getting requests or inquiries from some of their members on how their SMM mapped to the 62443 series. They knew of the existence of the series, but hadn't really done a deep dive into the requirements of the series to fully understand it. They did take a look at the 2.1 document, the 4321, which is the asset owner policies and procedures. And they took a look at the 62443.3 document, which is the system security requirements. And they tried to do at least a very high-level mapping to to the foundational requirements within the 3.3 document. So just at the sort of like top level, not requirement by requirement view. And they also took a look at the different elements and sub-elements within the 2.1 asset owner policy document and try to take a look at those and do some cursory mapping. But they found that it wasn't comprehensive enough to really provide a good mapping to their security maturity model. So they came to us and basically said, well, we would like to do this. Our members are coming and asking for this. And we feel that what we've done to this point really is not as complete as it needs to be. So they came to us and basically said, okay, well, we'd like to work on this with you. So taking a step back and kind of looking at their security maturity model, you'll see that it really is very similar to almost every other security requirements document that exists for cybersecurity. They have their own specific organizational structure, and it's geared more towards product supplier thinking. But when you actually delve into the requirements themselves, they do map very well to almost every one of the different security requirements documents that exists. And that's actually something that I found as I've done a lot of different security mappings, is that when you actually look across the board, 80–90% of the requirements are all about the same. They may use some different language, some different terminology, different jargon, but you're not going to go into a document and find that there's this miraculous requirement that you've got to do access control, or you're not going to find something like, oh, you mean I have to do patch management? Everyone sort of talks about a lot of the similar kinds of concepts. So going back to the SMM, they have this very product-driven grouping that they have. And so they've broken it up into governance, enablement, and hardening. And then from there, they break it up a little bit more. So under governance, they've got strategy and governance, threat modeling and risk assessment, and supply chain and dependencies management. Within enablement, they've got identity and access management, asset protection, and data protection. And then they talk about hardening. And so that's vulnerability and patch management, situational awareness, and event and incident response, along with continuity of operations. So they've really thought about this in terms of how a product should be built, and how that an organization can use these requirements to help build a more secure product. This is just a reminder that if you have any questions, go ahead and drop them into the Q&A box. So one of the things in the way that the SMM is sort of built is that they have what they call comprehensiveness levels. And you can think of them similar to maturity levels, but really they are focused on the specific capabilities that are built into the devices in order to improve the ability for them to be more secure in use. So they use a level 0 to say, okay, no security practices applied. And then their level 1, they have basically that you have a minimum set of security practices applied. And so this is sort of like that lowest level capabilities built into a device in order to satisfy the very basic kind of cybersecurity practices that you would want in a system. And there's no assurance of those activities and how well they're actually implemented. You're going on the word of the product developer that they've done these things. Level 2, level 2 covers the most common use cases of this device and how they would deal with well-known security incidents. So this is the very this is what you would expect to see from a well-designed device in terms of security capabilities. So the way that they've added in, well, we'll get to some examples later, but basically this is the normal sort of security capabilities that you would expect to be in a device. Now, level 3 is what they call consistent, and this is where you're dealing with a system that not just has that sort of basic cyber hygiene capabilities, but has the ability to actually be integrated with other devices in a network to be secure. So this is where it's designed for implementing, they call them best practices. The new term is just sort of like industry accepted practices. Many of the standards and regulations around cybersecurity and integration of cybersecurity features and regulations would be sort of at this level 3. And then level 4 is sort of you're going above and beyond those normal kind of the functionality in terms that allow you to that allow you to have continuous monitoring. So or continuous monitoring, continuous support, continuous enhancements. So this is that sort of like leading kind of design where you're looking towards the future. You understand that there's going to be changes, and you've built all that whole process within your device and your design process, so that you can actually improve and be leading edge for longer. Now, in addition to the comprehensiveness levels, BSMM also defines scope levels. And one of the things they found is that there may be requirements that may be applied to, say, only certain industries, or maybe you get down into actually being able to say that there are application-specific requirements. And so these would be level 1 are sort of the broadest requirements that apply across the board, across all verticals. And then level 2 is the ones that may be sort of like 1 or 2 industry verticals. And then the system specific would be an actual like language that you might want to try and put into the into, say, an asset owner's request for proposal, or an actual design spec. So this is where you would actually get down into the very specific pieces of how you would actually apply it within a system that you're actually building. So this is the way they've kind of organized it. So throughout their SMM document, they have a whole series of tables with, say, the practice name, a description of the practice, and then they break it down into each one of the different 4 comprehensiveness levels, along with, say, an objective description, and then they lay out the actual general considerations, so what needs to actually be done to achieve each of the levels. And then they actually get into considerations. And so these are taking a look at the requirements themselves and saying, okay, what kind of evidence do I need to actually show compliance with this requirement? So it's not just providing that basic, here's the requirement. They actually get into how can you show compliance against that requirement, which is actually really useful if you've got an organization that is trying to actually go through an assessment or do a self-assessment. They don't have to, they're not just looking at it and saying, okay, well, what is this really trying to get at? They can look to say, okay, well, if we have to do description of network segmentation for this device, well, maybe you're using firewall rules or you're using network captures or something like that, that you can then use as that way to show that you're accomplishing that specific requirement. And then on top of that, they also lay out the industry-specific considerations and system-specific considerations along with the general considerations in their table. So now, getting back to the actual process that we followed. Well, since we took a look at the security maturity model from the IoT group, what we found is that it doesn't directly map to any of the documents themselves within the 62443 series. The documents are laid out to the point where we do talk about different roles, but if we take there's no like one-to-one mapping between a requirement in the SMM and a requirement in any one particular document within the series. Usually it was some form of many-to-many relationship. So what it meant is that we had to actually go on a requirement by requirement level, and even getting into the comprehensiveness levels for each one of the 62443 requirements. And so it actually meant sort of a fairly intensive effort to do that sort of many-to-many mapping. And what we basically did is we took a look at the requirements within 62443. So we would start with a particular document within 62443 and then go through each one of the requirements within that document and evaluate it against the SMM comprehensiveness levels for those different sections. So first we would sort of like relate it to the security maturity, their sections, and then from within that section we would actually go through and sort of try and identify which specific comprehensiveness level for each one of those categories it would actually fit into. And so what we did is we came up with this, this consolidated requirements mapping that allowed us to sort of relate to the different 62443 roles. So what we ended up with is basically 4 different sets of mappings. So it's not a small document to get through for this mapping. The whole document's about 90 pages, and probably the bulk of that is the actual mapping effort. There's some ideas of how they sort of relate in the beginning, but as I said, the bulk of it is how we do this actual mapping. So we had the common mappings across the board to basically asset owners, product suppliers, and service providers. And when we looked at that, we looked at the 3.3 document and the 4.2 document. So 3.3 being the technical requirements for a system, and then 4.2 being the technical requirements for a product developer. That allowed us to come up with at least a base set of requirements that applied across the board, across all of the different 62443 roles. And then what we did is we had a set of unique requirements for asset owners. And so we used 2.1 as the base for that. But then we also looked at 2.4 and 4.1. And so the idea here was that 2.4 is the policies and procedure requirements for service providers, and 4.1 is the policies and procedures for for product developers. And 2.4 was being looked at from the asset owner point of view, because this is what an asset owner would need to incorporate into their sort of requirements for their service providers that they needed to incorporate in terms of IoT kind of implementations. And same thing with 4.1. It was looking towards the types of processes that a product developer would need to have as they're building out products that an asset owner would incorporate into their systems. And then we had unique mappings to product suppliers. And of course, since we've already got the technical requirements for product suppliers in 4.2, this one was mostly considered to be the policy and procedure types of requirements for product suppliers. And then the last one we did was unique requirements specific to service providers. And again, this was similar to the asset owners one, where given the requirements for service providers, they're going to need to be paying attention to what their product suppliers need to incorporate into their system and the processes that they need to have as they're developing IoT products. So we'll kind of jump into an example here. It's probably easier than trying to just go through everything. And I only picked one of the sets here. And what I did is I just sort of mashed all of the requirements together. So all of the requirements in all 4 sets of mappings, I just sort of put together into one big list for each one of the different comprehensiveness levels. So at a bare minimum, if you were going to do some form of monitoring in your environment, you would need to incorporate timestamps into a device, into the system. You would need to have access to some form of audit logs, and you would need to have some form of reporting that relates to event management. Now, these don't have to be centralized at this point. You could be entering timestamps as hard-coded times within a device. Maybe you log into the device and change the clock on that device manually. Maybe you have to log into the device and actually look at or download audit logs. But you have to have the ability to have these kind of things in your system if you want to do some form of monitoring in your environment. So this could be sort of geared towards the lowest level devices. So thinking Purdue model, maybe your 0 and 1 devices in this point, you have to have some way to identify a time for that device, and you have to some way to collect some sort of logs in that device. And whether you're plugging into that device via serial or Ethernet or some sort of bus architecture, that device has to be able to at least have these minimum set of requirements if you want to use it as part of a monitoring infrastructure for cybersecurity. So moving up to the next level, this is where we're now starting to actually get into having more common types of cybersecurity requirements related to monitoring. So they have a whole section on wireless devices within the SMM, thinking through IoT devices. Of course, a lot of those happen to be wireless. So they have some specific areas around it towards wireless devices. So their first idea around wireless devices is that they have to be able to actually identify and report if there are unauthorized wireless devices in the network. So say you have a router that a lot of these wireless devices go through, you have to be able to monitor and identify and report if there are unauthorized devices getting access to the system. And then you also have to then go through and deal with the idea of mobile code. And mobile code might be things like PowerShell scripts or different types of scripting, not specifically PowerScript or PowerShell, but other types of scripting languages. It may be Java, it may be other types of HTML code or something like that, that you need to actually monitor for. And so you need to basically have the way to actually go and do some integrity checking on that code. Now, moving away from specific like code things, now you get into, okay, you have to have a way to identify auditable events within a system. So not just like you did in the first level, now you have to actually be able to have some sort of event auditing that will allow you to actually identify different types of events and possibly even from a asset owner point of view, look to say what the criticality of those events are. And then there's some sections on basically if you are going to have these auditable events within a system, what happens when you start to overrun the storage capacity of your device internally? So now maybe you have a flat text, say you're dealing with Linux and you've got a flat text file in var logs, or you've got some sort of database of events. You need to know when there's going to be a problem storing those logs and storing those events. And so you need to be able to have some sort of ability to audit that storage capacity and warn someone that that storage capacity is reaching some sort of threshold, whether it's a high alarm or a high alarm or something like that. You need to be able to report that to someone to let them know that the system is going to start overrunning its log pretty soon. And then you need to respond to those audit processing failures in some way. So you have to have some way to clear logs or download and then kill the logs or something like that within your system. And then thinking through other things that you would need within a monitoring environment you have to have some way to deal with antivirus and malware protection software. And so understanding how you would actually have to manage those pieces of software in your system, or if you're not dealing with software that's applied to a device, how do you do monitoring external to that through the network? How do you have, what kind of processes do you have in your environment to actually monitor for those kind of viruses and malware within your system? And then similar to that, there's additional requirements in here about malware protection and security tools, installation and detection. And so at this point, again, we're dealing with mostly manual processes. They may have some automation to them, but you're not dealing with fully integrated, fully centralized kind of management and monitoring at this point. So now we come to level 3. And level 3 is where you're really starting to talk about centralized management of your systems. So no longer are you just trying to do some form of audit and auditing on the systems and event collection on the systems. Now you're actually trying to collect a lot of that audit and log and incident and threat information at a centralized location. As part of doing that, you're going to need to make sure that you synchronize your time across the environment. So understanding that in order to actually do any correlation of events across an entire environment, you need to be able to synchronize your times. That doesn't mean that every single device needs to have be precise to within a certain level. It means that you have to have the way to distribute time and a way for devices to understand their offset from that time, and then basically be able to adjust their logs accordingly. So they don't have to have the highest precision clock internally, but they definitely need to be able to work to understand their offset from that fairly decent time source. Along with the idea of that time, there's the idea of being able to make sure that the actions that are being taken within the environment are done by the person or device that says it is. And this goes along with the idea of a lot of it's malicious kind of intent, where logs can get adjusted by individuals, whether it's deleted logs or it is modified logs, in order to basically have the ability to say that, yes, this action was taken by this person or this machine at this time. As you go through and are starting to do this, the idea of forensic investigation throughout your system, and then rebuilding that timeline, this allows you to basically have a complete timeline without any holes in it, or any cases where you may be unsure of the person or persons that were taking that action on. Along with centralized management of events and logs, now we're going to start looking for centralized management and reporting of malware and malicious code protection. So the antivirus and malware protection software that's installed on the devices is not just going to keep those logs internally. Now they're going to actually report them to some sort of centralized management system for the idea of being able to track movement around a network. And along with the idea of that malicious protection, malicious software, malware, you're going to start looking at the authenticity of software and information within the system to make sure that you're not getting malicious pieces of code being pushed to devices or being downloaded. The non-repudiation, now you're going to be dealing with integrity violations, making sure that you've got automated notifications being sent out to that centralized management system. And this idea of the programmatic access to audit logs, this means that automated systems, centralized management systems, can either pull logs from devices with, say, like WMI calls to Windows systems, but they can also receive pushed notifications from, say, syslog from your network equipment, or syslog from different PLCs or devices. And the last two go along with the other requirements that I've already talked about. And now looking towards level 4, this is where now you're not just doing the basics of centralized systems. Now you're actually going and doing active monitoring of your system. So you're not, level 3 is being able to say, okay, I've got centralized management of all of my systems, but I'm just sort of sitting and waiting for the information to show up. Level 4 is now you're going and automatically and actively looking for things within your environment. You're dealing with continuous monitoring. You're dealing with active monitoring of your network, whether that's through passive network detection and alerting, or it is through actively going and querying systems. But this is the idea that you are actually looking for bad things on your network, not just sort of waiting around for them to happen. And similar with automated notifications of integrity violations. So you're actively checking your database, looking for changes to your system, looking for changes to hardware configurations, looking for tampering, all of these kinds of things. But this is this active, this is the sort of like above and beyond the just sort of having the capabilities in your system. Now you're actively going out and trying to look for bad things. And with that, that is the end of my official presentation. And I will open it up to questions.
Yeah, thanks, Jim, for that great presentation. That was extremely informative. We are going to move into the Q&A session in a moment. So to the audience, you can still send us your question. You can do that by entering it in the Q&A box and clicking submit. We'd love to hear from you. Even if you just have a comment, please send it in. And we're going to try to get to all the questions here, but if we don't get to your question for whatever reason, we will reach out after the webinar is over. Looks like we have a couple questions in the queue right now, so we're going to jump into those in a moment. But right before we get to that, I just want to also mention that on your screen in the top right corner, we have some additional information that you can follow up. The information shown in the slide is also shown in the resource list, and you can click on that content there, and we encourage you to follow up. All right, let's jump into the questions. Looks like we have a couple questions in the queue, so we're going to get to these right now. And here's our first question. Why are the IoT SMMs mapped to asset owners and service providers if the organization is more targeted at product suppliers? Jim?
Cool. So one of the things that the IoT organization was running into is that their product suppliers that they were actually working with and sort of supplying information to were getting questions from their subsequent customers on how do you actually use this in their environment. And since a lot of industrial organizations were looking to sort of incorporate IoT into their environments in a secure way, they were trying to figure out how they could apply this or how they could work with their product suppliers to actually make use of IoT in their environments securely. They knew that IoT tends to be more internet facing. They knew that IoT tends to be the devices themselves tend to be more open in how they communicate. And so what was happening is that the asset owners that were looking at the IoT, the IIC's like customer base, were asking these questions, and so they needed to find some good way of working with them. And being industrial customers, a lot of the organizations knew about the 62443 series, and so they were getting questions of, well, how am I going to work with this when it's it's written totally different, and it's written in ways that don't sort of map easily to the requirements that I already have from 62443 or from NIST SP 882 or the ISO 27000 series or whatever standard of choice that they had to, that the asset owners were being required to use. And so it was the kind of idea that 62443 being the premier industrial cybersecurity standard, they felt that it was the best fit for them to come to us in order to understand how their asset owners could actually make the best use of these documents.
Oh, very cool. Thank you for that. And thank you for that question. To the audience, we are in the Q&A session. You still can send in your question. Looks like we have one question in the queue left, so now would be your last opportunity to send in a question, and you can do that by entering it in the Q&A box and clicking submit. But for now, here is our last question. How are the IoT security maturity levels related to other types of maturity levels?
Okay, so I'm going to go back to the comprehensiveness levels slide. One of the things I mentioned here is that the comprehensiveness levels in the IoT SMM are written in terms of more the capabilities that a device or a product developer would need to incorporate into their processes and their devices. This is a little bit more akin to the 62443 security levels, but again, it's not a direct mapping. If we start thinking through an overall maturity model, the SMM requirements and the comprehensiveness levels are very different from, say, the CMMI, which is the capability maturity model. I forget what I stands for. It's very different from that, and it's very different from, say, like the DOE's C2M2, which is the capabilities, the cybersecurity capability maturity model, and it's very different from, say, the DoD's CMMC, the cybersecurity maturity model certification. Those models, they have basically a set of requirements that are more targeted towards asset owners, and it really is led up where they're geared towards the asset owner's policy and procedure and systems and what processes they have to put into place. And in addition to that, like CMMC and C2M2, those are measured in a different way as well. So C2M2 is actually measured using an actual grayscale kind of scale that's called, that talks about fully implemented, partially implemented, fully, largely implemented, partially implemented, or not implemented. So for every single requirement at every single maturity level, you can basically have this idea of how well that organization implements that particular process within an organization. And CMMC is very similar. They also have they have multiple levels within their maturity model. But the CMMC is actually a certification standard, so those are rated on a pass-fail criteria. There's no sort of grayscale on how they're rated. So it is difficult to do a sort of comparison between what the IoT group calls a maturity model and other maturity models that exist. And this was where we were struggling with how to actually proceed when it came to dealing with our mapping to the 62443 series. We think we've come up with a way of doing it, but even within 62443, we've got, we use a maturity model that's mapped to the CMMI model, which is more of that grayscale. How well is the organization applying its particular security policies in their designs? So hopefully that answered the question.
Wow, that was great. Yeah, thank you for that. Let's see if we have anything else here. All right, looks like that was our last question, so we are going to wrap things up right there. So Jim, once again, thanks so much for being here and sharing your knowledge with us, and also taking the time to answer a couple questions from our audience. And of course, we'd like to thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you can come back and watch this again or share it with your colleagues. And lastly, please take a moment to complete a survey, which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widgets. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.